CERN is looking for dark matter. And the question is, will they find it? I think they will find it. Probably so. That is the answer. But why are they so intent on finding dark matter? What's wrong with regular, other experiments that they're doing? Why do they want to find that dark matter? That's what, look at it, you all. You can see this right here. Let me blow this up a tad bit. Let me move myself out of the way. Gonna blow this up. This is just like a little bit of what dark matter kind of looks like. It looks kind of like dark plasma. It really does. It's black and stringy. That's the only way I can describe it. And it's everywhere. Dark matter is everywhere. Let me come over here. Let me turn on this channel that we're on right now, you all. So I get these comments on here so I can see. Make sure we got people in here. We got people. Turn on this channel. Whoopsie. Sorry, you all. That's right. Let me come over here and close this out. I'm going to come over here to the live chat. Welcome. We're going to look at this because I think you had the Georgia Guidestones. Can y'all hear me? The Georgia Guidestones. K. Canaver. Well, that's wonderful. Hello there, Nature Spirit. Yeah. So you had the Georgia Guidestones that, one of them blew up yesterday, and then they took the bulldozer and they bulldozed the rest of it down. If you remember the videos that's been going around. Look at this. So we got CERN over here. We're going to go straight to it. Right here. Look at that. This is the image that I used. So I'm going to copy this, and we'll start putting the links in here for those who, want the links in here. We're going to do it. That way there's no doubt where Gina Honey got her information. Okay, there will be no doubt. Okay, let's come over here. So we looked at some of these images. And these are, yeah, look at that. Scientists find the missing dark matter from early universe. They find it. Look at that. Does that not look like, you ever see the video that I did? The birthing of dark plasma? They had little clumps. There were little clumps when he's watching the plasma webs forming. This one plasma web formed above a body of water in I forget the country, maybe some kind of Dutchland, Netherlands or something. And it had started having contractions. Plasma is intelligent. It had contractions, and all of a sudden, dark clumps of, looked like dirt, literally crawled out from underneath it. It gave birth. It did. It gave birth to these dark clumps. Now, granted, there's like dark strings right here, but let's look at this. Let's go back over here to this article. We're right here. Let's come over here. I went right there, but this is the main search I found. I'm going to put this in here too. This is where this came from too. You're just going to put this, document everything so that no one is saying where you got the information. We're going to document it. Come over here. Look at this. CERN is firing up its Large Hadron Collider at record levels, energy levels, in search of dark matter. In search of dark matter. Black goo, it could be. Look at this, July the 5th. So we've saw some articles written about CERN. It has been in the news. CERN's been in the news. Then all of a sudden we got the Georgia Guidestones. We're going back to CERN. CERN lights up the Large Hadron, however you want to say it, Collider for Run 3, a 4-year continuous run after its second long shutdown. Right there. The world's largest particle accelerator, the Large Hadron Collider, is back in action after a 3-year break from maintenance and an upgrade with more energy, higher intensity beams, and greater precision. the LHC at CERN outside of Geneva is set to run 24/7. Oh my gosh, you all, 24/7 for nearly 4 years at a record energy of 13.6 trillion electron volts. The upgrade should give the LHC tools greater precision and allow for more particle collisions, brighter light, and more discovery about particles in quantum field theory. 4 years straight, you all. They're going to be using up all the energy. We probably are going to have some blackouts and brownouts and grid downs. If they've got all that energy, where are they getting all that energy? Really, I'm serious. Where are they getting all the energy? So CERN is used, the LHC, to discover the Higgs boson on July the 4th of 2012 before its first long shutdown. Back then, under LHC Run 1, the LHC was operating at 3.5 trillion electron volts. 3.5 trillion back in 2012. And now we are at 13.6 trillion. So that's a lot more. Okay, that is a lot more. It's around 4 times as much. Okay, around 4 times as much. Now it's time for Run 3 at 13.6 TeVs or 6.8 TeV per beam. Hello there, Applebrooks, honey. Also, on July the 12th, we'll see the universe like never before. July the 12th? We are going to see the universe like never before? So let's read the rest of this. We're going to go to that. We're going to look at that. We'll come back and look at that when you are. Rende Stierenberg, head of the operations group in the LHC Beams department, said that with 6.8 TeV for Run 3, it wants to push the LHC up to 140 billion particles per package or per bunch. From 2023 onwards, it wants to increase this to 180 billion particles per packet. This will, of course, give us many, many more collisions in the experiments. Why do they want to have many, many more collisions? So they can up their chances. An electron volt is a measure of kinetic energy gained by an electron accelerating from rest. Hence the need for an accelerator like the LHC with its 27-kilometer circumference, which accelerates hadron particles such as lead, xenon, and oxygen ions at different levels of the mass spectrum in a way that forms 2 beams traveling in the opposite directions, almost at the speed of light. The beams collide in the machine at 4 points or detectors called Atlas, CMS, ALICE, and LGCB. So there's 4. The beams are colliding at 4 points. So these are all in different levels, different areas. The Atlas, the CMS, the ALICE, and the LGCB, each of which focuses on measuring different types of hadron particles. IBM and CERN use quantum computing to hunt elusive Higgs boson. It's the Higgs boson particle or wave quantum field theory that thought to give mass to particles that form the basis of stars, planets, and everything. When 2 electrons interact, for example, they exchange particles of light or photons that are the force carriers of an electromagnetic interaction. They want stable beams. They are focusing the proton beams at an interaction to less than 10 micron beam size to increase the collision rate. If you're just tuning in, they're going to search for their dark matter 24/7, and they've increased their energy speed, whatever, by at least 4 times, maybe 3.5 compared to Run 1. The Higgs was discovered with 12 inverse femtobarns. Now in Run 3, we'll be delivering 280 inverse femtobarns 1. And it's a significant increase, paving the way for new discoveries. CERN says that its Atlas and CMS detectors, they say it expects it to record more collisions during Run 3 than in the previous 2 runs combined. how 3D printing is helping CERN scientists upgrade the world's largest machine. So they got a data taking rate factor of 10. And Alice is aiming for a 50-fold increase in the number of record collisions. They hope to answer questions of the origin of matter, asymmetry in the universe, and search for the candidates for dark matter. We're looking for measurements. We're looking forward to measurements of the Higgs boson decay to second-generation particles such as muons. This would be an entirely new result in the Higgs boson saga, confirming for the first time that the second-generation particles also get mass through the Higgs mechanism. So that's what they're doing. They want to, let's see this. It's, you get the early Prime days of Amazon right now. So let's see this, you all. They're looking for dark matter. That's what this universe. This article was about dark matter. Let me get a drink. We can see right here. They want to search for the dark matter. Right there. They're searching for it, but we wanted to see on July the 12th, they've got this article right here. We will see the universe like never before. Let's put that in here. They're going to see the universe like never before. And thank you for coming on here. I know it's kind of early. Oh, that's okay, you all. I normally don't do a video like this in the middle of the afternoon, but I'm doing it. They're going to see it like never before. Well, Carol, honey, it's not about feed the starving. It's about, someone once said, technology must increase no matter what. They're not going to stop it. They're not going to stop the advancement of scientific discovery and technology. They won't do it no matter what. So NASA and its partners will soon release a set of images from the James Webb Telescope, the deepest image of our universe ever taken. So this is James Webb Telescope on July the 12th. So that'd be neat if we can see it. It's the furthest humanity has ever looked before. Nothing short of real scientific feat. They launched it in spaceport in Kourou. So this is about NASA. The photos will be released were chosen for their spectacular color imagery, and NASA said, as well as to demonstrate the breadth of science that this telescope is supporting. We're only beginning to understand what the Webb can do. It's going to orbit exoplanets or orbiting other stars, clues to atmospheres and stuff like that. You all, what is out there? Look, where do we come from, and what more is out there, and who are we? Well, some of us would say that, we don't belong here. Okay, but then some of you all probably, those type of people, they probably are from another universe. They probably are, and they're here. So that's really interesting right there. But this right here, they got looking for their dark matter. And dark matter is unpredictable, you all. It's totally unpredictable. Let's look at this. So let's take at this. CERN and dark matter. Dark matter is unpredictable. They don't really know about it. It's all new. Are they trying to unveil? This is today. Are they trying to unveil the mysteries of dark matter? Let me just put this here, right here. It is the invisible cosmic scaffold that holds together the galaxies and galaxy clusters. We just don't know what it is. They note the nature of dark matter remains one of the most compelling scientific mysteries. The identity of dark matter is viewed as one of the most important, outstanding questions in modern physics. They want to know what dark matter is, you all. They do. Let's look at this. They want to know what it is right there. And I think that that right there, CERN, is really still the big story going on. They're going to be the big story for 24/7, 7 days a week. They're going to be the big story. Is this what we clicked into? Right there, you can see the thing. 17-mile circle. What the heck is whatever? Oh, we got Utah. We're just trying to see down here. What we don't know about dark matter is a lot. It's an outstanding fact that the vast majority of matter in the universe is actually invisible to us. Astronomers think dark matter must be present because they say they see its gravitational fingerprints. Dark matter is the invisible cosmic scaffold that holds it together. It remains one of the most compelling scientific mysteries. So that's what they want to know. They got the identity of dark matter is viewed as one of the most important outstanding questions in modern physics. If dark matter is a new type of a particle, see, they want those particles, you all. That's what they want. They want those particles. That's why they want to smash so many, because they want to find it and capture it. And I'm sure it replicates just like plasma. Plasma can replicate. They want to replicate that dark matter if they can only catch it. That's what they want to catch it. If dark matter is a new type of particle or particles, that would give us incredible insight about the nature of physics beyond the standard model. But by virtue of its darkness, the dark matter is very hard to detect. It rarely interacts with standard modern particles, making it challenging to discern its presence in a particle detector. They want it, you all. They really do. Intriguingly, Space.com reports experiments on the smallest scales at the Large Hadron Collider could hold the key to figuring out one of the largest scale cosmological mysteries of all. Look, since the discovery of the Higgs boson, the field of dark matter has changed completely. Gian Guidus. What a name. Gian Guidus. Hey, that could be Gina. G-I-N-A. The words are just twisted. They're just a little backwards. Let's unscrabble that. With Gina's guidance, who leads the theoretical division at CERN, told a press conference at the end of June. Yeah, it has changed completely. 10 years ago, the lead contender for the identity of dark matter was a class of particles known as weakly interacting massive particles, or WIMPs for short, according to a report by Space.com. These particles with large masses, hence the dark matter's strong gravitational pull, but which otherwise would only weakly interact in a couple of other particles, you all. So they've got this... it's their new thing. It's going to widen their horizons, is what it's going to do. Massive collaborative effort to engage in science for peace. Look, all these scientists from around the world, you all. Around the world. Wow. It's a fact. In just the first day, you all. All of that. They are going to focus on advancing the boundaries of human knowledge by delving into the smallest building blocks of the universe. That's what CERN says, and it's going to be very interesting. I'm really interested in it. I am, and I'm sure a lot of other people are interested in what CERN's going to do. Whether it's for the better or for the worse, we want to know. We want to keep up to date on it, especially with them dealing with dark matter. And there's lots of plasma out there, too. There is. That's right. That's right, you all. Bridget Manfredina, honey. You can't even let me get some of my pressure washing done, Bridget, honey. I will give you a break. I promise. I got to go do stuff. I wanted to hop on here really fast. I did. Absolutely, I did, you all. It's okay. We're going to keep on top of CERN, especially they're going to find this dark matter. That's why they're smashing thousands of particles like that, and they got all these different areas that have their own specific job they're going to do with this parking, with the smashing of them. I'm going to go, you all. Thank you so much for coming on here, and thank you for your comments, and thank you for your insight, because this is really, I think what they're doing is probably one of the most important scientific feats that humanity has ever done. Do I agree with them searching for dark matter? No, I don't. But it's something that we need to watch very carefully, because as they search for it, since it's so unpredictable, it could sneak in the opening portals and stuff. And I think they really don't know the full effect of what's going to happen. There might be one or two entities that might, but it's unknown. It's unknown what the outcome will completely be, and we may not be able to handle it as a civilization, the end result. So with that being said, I am going to go, and hello, wherever you are in any part of the world. Hello. From my heart to yours, love. You have a wonderful rest of your afternoon, and you can go get your power washing done, Bridget, honey. You can do it. I would encourage you to do it. That's right. While you're in the mood, and if you all got stuff to do outside, I'd do it too, or around the house. Yeah. Have a wonderful afternoon, you all. Love you, and thank you out.